Hello IB, welcome back. It's been a while since we've had a video. So here we are starting our 12th topic on probability. There's going to be two sections of probability. One will start now, which has got a lot of repetition from year 10 work, but we'll also be extending it. And then our second part of probability we'll be leaving and doing after our trials. So probability is very closely related to statistics, as you would have seen over the years. So especially in, say, this example here, which is all about the insurance industry and working out premiums for life insurance. So they need to gather a whole lot of statistics on how long people are expected to live, and based on that is how they come out with their premiums. So if we go to these links, I'll show you this first one for the males. So this one here is for males. This is an Australian government website. So at the age of 0 with 100,000 people, then these are all different probabilities, but basically over here is our expectancy. They're expected to live for an 80 years. So this is an average expectation based on the 2010 to 2012 data. And as you can see, as they get older, by the age of 10, so a 10-year-old in those years was expected to live another 70 years, which sort of matches up. Then we get up to, say, a 20-year-old. They're expected to live this much longer. And so when we get up to the 80 years, so down here at 70, they're expected to live another 15 years. So if they've made it to 70 years old, they're now expected to make it to 85. So if we get down to now an 80-year-old, they're expected to live another 8 years to 88. Once we're up at 90, they're expected to live another 4 years. Anyway, so they get a whole lot of data like these and then work out how much premium to charge them to be paid, for them to be paying through their lifetime, so that if they died early, what would be the payout. Anyway, so statistics, probability, closely related. Running through a couple of definitions, remember probability is often come up experimentally because not every situation is going to be ideal that you can come up with a theoretical. The probability is either going to be 0, this is the chance that it can never happen, so this is never can happen. So if you've got a heads and tails, then I don't know, let's say if you've got a piece of cardboard which is black on one side and white on the other side, there's no chance you're going to get a red side showing. So 0 probability or 0%, up to 1, which is certain that it will happen, and that's going to be our 100% or 1. So we can also use a decimal or a fraction for probabilities as well as percentages. We're going to start using this notation. Note here we've got a notation that's similar to what we've been using with functions. So this function notation we're going to bring into probability, and the value of that function is going to be between 0 and 1 inclusive. Probability is either going to be calculated experimentally or theoretically. So if we can come up with a rule. The terms here, numbers of trials, that's going to just simply be how many times that you are testing this, so how many trials of the experiment you're actually doing it. The outcome, that's all the possible results that you could get. The frequency is how often those particular results happen. The relative frequency, do you remember that one? Relative frequency is going to be a decimal or a percentage, and the relative frequency is what we call the experimental probability. So it's when we do an experiment. The relative frequency is calculated from the frequency of outcome, so how often that outcome actually happens, divided by the total number of trials you did. So if you've tossed a coin 100 times and you get 20 heads, then the relative frequency was 20 out of 100 or 0.2 or 20%. So again, that can be a decimal or percentage. The examples of experiments, the textbook runs through a whole range of experiments. One here is tossing two cones. So here they're being tossed and they can either land on their side or on their head, or on the base at least. In this example, they did 279 trials of throwing it up and see how it landed. The outcomes, side or base. The frequency, how often they got a side, was 183. So the side happened 183 times, and it landed on its base 96 times. That sort of makes sense, just looking at the shapes of them. The relative frequency is, of course, the frequency divided by the total number of trials, which was our 279. So that's total number. And here it's approximated to our decimal in three significant figures, or 3 decimal places in this case. The relative frequency of landing on the base was 96 out of 279. So given that we don't have any other data, or we haven't done a mathematical calculation of the surface area and the angles and everything, our relative frequency is going to be our best estimate for the probability. Another common one we'll come across are tossing two coins. So let's use this example here just to go through some other basic concepts that you would have done earlier. So to calculate experimental probability, you can just toss your coins, and let's say we tossed the coins and found out we had a frequency of 26, where we get we get two tails, so the number of heads is 0. Getting two heads, we ended up with 50, so we've got a tail and a head means we've got one head, and the frequency was 50. And when we tossed it, we found getting two heads happened 30 times. So if we want to calculate the relative frequency, we need to know how many times we tossed it all together. So this total, you can add up, and it comes to 106. So that means our relative frequency here then must be 26 over 106. You can simplify that, but it's okay, you don't have to. The relative frequency is going to be 50 out of 106. And the relative frequency of the two heads was 30 out of 106. So that's dividing it by the total number. What about the cumulative frequency? Do you remember that? So remember, your cumulative frequency you get by adding up your frequencies. So we started with 26 that had no heads. By the time we've got one head, that means 0 and 1, we're adding the 26 to the 50, gives us 76. And now we add the 30 to the 76 to give out 106. So the frequencies are being added up in order, and this number here should always be matching the total you get over here by adding your frequencies. If they don't match, you have a problem. You can present this data on two different types of graphs, your frequency histogram and a cumulative frequency histogram. I better put frequency in here as well. Cumulative frequency histogram. So your histogram, remember, are those bars, but they all join up and they're on a continuous scale. So here, because we want to do 0, 1 and 2, along here is our number of heads. So that's what's on this axis. So we're going 0, 1, 2. And then when we draw the bars in, we want to make sure they join up and they're straddling the value on the x-axis. On this axis, we've got our frequency. So our frequency here, the highest frequency we've got is up to 50. So let's just go 25 and then up to 50. It's about even. So our first bar, on how we're going to test my drawing skills now, is up to there and comes down halfway between the 0 and the 1. So this is meant to be a height of 26. The next one goes up to 50. So that means this continues up to 50. And if you have a ruler, which hopefully you will have for exams, you can use your ruler there. So that should have a height of 50. And our next one at 35 is going to probably come across about here. So remember, they need to straddle the value on the x-axis. So that's in the middle. If you wanted to do the pentagon, remember for this one, we join up the middles. So that let's even use a straight line. We'll go straight line. Let's get some colour in here. So that joins up the middle there. Joins up the middle. Hold it, I've lost the edge of that one. Joins up to the middle. And then this joins to the middle here. And then it comes back down to the bottom there. All right. So that's your frequency polygon. Frequency polygon. We'll be coming across that again later, but let's just put it in now just to remind you. Let's now go to the cumulative frequency histogram. So again, we've got the number of heads on our x-axis. But on this side over here now, we're going to have, let's try and write it sideways, we're going to have our cumulative frequency. So that means our total's got to go up to 106, which is our maximum the maximum for the cumulative frequency. This is going to be a bit below half, where 50 is. And let's do our 0, 1, 2. And our first bar is just going to be the same, going up to 26. That's about halfway. Our next one needs to go to 76, which is about there. And then the last one comes up to our 106. So that one there is 76. And this should be 26. So we can express them there. We'll come back to the polygon for that. So your experimental probability versus your theoretical probability. Remember that the more trials we do, then the closer the experimental probability is to the theoretical probability. You're going to come across the different types of experiments. We've done tossing coins with heads and tails. The textbook includes tossing drawing pins, so they can either land on their back or on their side. Or you may get a spinner where you've got different colours in each of these sections here. So that, you might have a red colour here, and we've got the teal. You might have two sections of blue. Anyway, I'm sure you've seen spinners before, and my colouring in leaves a bit to be desired, but I didn't go over too many edges. All right, so there's those ones. Also, rolling dice. You can rolling 2 dice, and you can do that and do a whole lot of trials to come out with those probabilities. So we won't be taking time with that, but it's again another experiment that you could do. You can also do drawing cards, so that also comes up. So you are expected to know that the cards, you've got 4 suits of cards where you've got your clubs, spades, hearts and diamonds. That you've got 10 cards Then your picture cards are your Jack, Queen and King. So a knowledge of cards is good to have for some of these probability questions. In 22B, we're looking at sample space. So I just want to quickly run through this. The sample space is a set of all your possible outcomes in an experiment. It's called the universal set. Sometimes it's easy just to list your sample space. Other times it might be best to draw up a table. So if you've got two parts to an experiment, here like tossing one die, heads or tail, and a coin, heads or tails, and one die, 1 to 6, then we can see here we've got 12 different sorts of outcomes. 2 options for the coin and 6 options for the die. So 2 times 6 is 12. You could be tossing a coin and doing it 3 times. So in this case, that won't work out easily in a table or grid, but doing a tree is a good method. So here we can do the first toss in this case. So that's your first toss, and then you toss it again, and then you toss it for the 3rd time over here. Your sample space in this case is you could have head, 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 which is 3 heads. Here you can go head, head, tail. If you follow along these branches, you're going head, tail, head. Then head, tail, tail. So now we can see the 8 options. We've got 2 options times 2 options times 2 options. So there are 8 options that you could get in your sample space. Here, if we've got 3 children in a family, what's the probability of getting 2 boys and 1 girl? This is very similar. Instead of doing heads and tails, we now have boy or girl. Let's shift this out of the road up here. So boy, girl, etc. So your sample space will be much the same. You could have end up with 3 boys. Work along each of the branches. So let me fill that. So here I've filled those in for you. We get all the different options here, and again we see the number of outcomes we could have had. We've got 2 options for the first child, times 2 options for the next, times 2 options, so that gives us our 8 options. And if we want the probability of getting 2 boys and 1 girl, and it's not particularly describing what order, then here we have 2 boys and 1 girl, 2 boys and 1 girl, and 2 boys and 1 girl. So we end up with 3 out of 8. That's the probability of getting 2 boys and a girl. Note the girl is either 3rd or 2nd or 1st. There were like 3 places where we could have the girl. So hopefully you've got some notes on that. Hopefully a lot of that is familiar to you, so we can move quickly through it and then springboard into the new work. So thanks for listening and looking forward to seeing you in class. Bye for now.